Okay. So this is what we have as a canister. So here we write code, and with this code, let me just try to enlarge this so that you can all see. So the code is written here by the developer, and then it's installed like I was demonstrating to you. Here on this side, we have memory. And one important thing, and also we'll talk about it, we have this module that is called a WebAssembly. WebAssembly makes it easier for us to have multiple languages writing or creating code that can be understood by all the canisters. And then on the side here, we have users that can write and read what is in the canister. And then we can also create some decentralized application and also have them in the same canister, and we can interact with them as users. We can run them either in one canister or on multiple canisters. So this is why it's important for you to understand a canister, and this is just the overview of how a canister looks like and what it is capable of doing. So when we look inside here, we have what we are calling WebAssembly, right? So WebAssembly basically is a module, which is a piece of compiled code from languages. So on the internet computer, you'll find out you can write using different languages. And I'll just write some of the languages here that you can use on the internet computer. There is Rust. For those of us who are really strong, use Rust to write on the internet computer your code. Then we have Motoko, which is what we are learning in this course. And this is native to the internet computer. Okay. You can also use TypeScript, which is something that was recently developed. And the language is called ASO. Okay. And then you can also use Python. And the language is called Hybrid. So these are the names on the internet computer. But for Rust, it's still Rust. And this is native to the internet computer. This is a language that was specifically created for the internet computer. And despite having all of these languages, okay, somebody can write, they can write their code in Rust, they can write in Motoko, TypeScript, or Python. And they can all run in the canister, or they can also interact with each other, despite of which language was used to write, because of WebAssembly. So this is kind of the code that is installed in the canister and is ultimately running. So whenever you're done compiling and running and installing your code, then it is running as WebAssembly. And this is universal to all the languages that run on the internet computer. And a WebAssembly memory, also called memory pages, this is where the state of the canister is stored and files are stored. That includes photos, videos, tokens. And codes run by the WebAssembly module will modify the memory that is within the canister. Okay. So we spoke about Motoko, and this is the language that we are mainly going to be focusing on in this program. And while we are learning about Motoko, there's so many other concepts also that we are going to encounter during our sessions. So with Motoko, mainly you will see all the files in Motoko when you're writing in Motoko. there will be they'll have an extension of .mo. So this an example of a file. It can be main.motoko. So mostly when you open a Motoko file, you will see that it has this extension of .motoko. Now you know that this is a language that was written, that this is a language called Motoko, or the code that is in that file is Motoko. So, and Motoko is also just a high-level language, just like JavaScript and Python. And it is, I consider it's kind of easier to learn than Rust. Rust is kind of more hard to learn as compared to Motoko. Okay. So when you're writing code in Motoko, allow me to switch to this Motoko playground. Just give me a moment. So like I said, in the morning, Mr. Enoch showed us how to install our local environment so that we can get started with writing code on the internet computer. And we have what we call the Motoko Playground. We'll share the link to it. This is kind of a faster way for you to just test out something that you want to test out. If you have, let's say, just a function that you want to test and you're just writing it out and you just want to test it out real quick, you can use this Motoko Playground. You will see me use it more often when I'm just showing you examples during our sessions. But what I want to speak about is what we call the actor model. Okay, so I'll put some comment here. So if you open any Motoko file, there is highly a probability that the first word that you will read is actor. This is how it's written. So mostly all Motoko files, they have they always start with the actor model, or you'll see the word actor, and then you'll see opening and closing curly brackets that will contain all the code for that application. So here, this is where all the code comes in. They all are enclosed within what you call an actor. So whenever you're writing your Motoko code, please remember to put it within an actor model. You can look up on the internet where it is called an actor model, which in a way was derived from a way to write computer programs that can handle many tasks at the same time. So you can go ahead and research about the actor model. Okay, so you also see that canisters, or the canister that is going to be used to install your code and run within your code within that canister, they have been all implemented to follow the actor model. And you'll see that canisters have private memory and can run a lot of computations. They can receive messages from users, like I was demonstrating. If we have a user who's interacting with an application, they can send messages to that canister, and then the canister will give us back a response. And they can also communicate or send messages to other canisters. They can also receive messages from other canisters. And also our canisters can send messages to users and other canisters, and they can create also other canisters. So if you just want to take a look at some of the things that our code can do. Let me just refresh this so you can just see some of the examples. When you go to Motoko Playground, I don't know if we have some example projects here, like Hello World, a counter, a calculator, who am I, phone book, and stuff. If you open all of these examples, one of the things that you see in main Motoko.mo is it starts with an actor. And also you can name your actor. Like here we have echo at the beginning or before the opening curly bracket. And then we can have all of these whatever part of our code. But what's important is we have an actor and we can give it a name. Sometimes if you want, you cannot give it a name, but usually it's best for you to give your actor a name, which is here where you put your name and then you write the rest of your code. Okay. So there's a number of things, like I said, also that you can do on a canister. You can do query calls. You can do updating. You can update your canister. You can update. Oh yeah, you can do querying. You can do updating, and those are some of the functions that you can implement or you can use on a canister. Okay, for the moment, I can take questions. Any misunderstandings? Any questions about a canister or how a canister works? We just thought it's very important for you guys to understand how a canister works.
So I'm a bit behind on what a canister is.
Well, which part did you not understand? So,
what a canister is. The definition of a canister.
okay. So basically a canister, this is where you can run your code. Just think of it like a server where you can install the code of the application that you want to write. So instead of servers on the internet computer, we have what we call canisters. So within this canister, this is where an application can be contained. So when you run an application on the internet computer, a canister is created, and within that canister, that application will be installed, and then users can interact with that application. So when they are interacting or sending messages back and forth with that application, you will be interacting with the canister.
Like, just also add to that. Yeah. So you can also think of a canister as well as I don't know if you're familiar with the Docker container, right? An environment where like your code that is bundled up can run, right? So yeah, you can think of a canister as that as well. It's like a Docker container, an isolated state that is running your code, right? And in Web3 terms, you can also think of a canister as a canister is like smart contracts, but on the internet computer, you see. So on Ethereum, we have smart contracts. On Solana, on all these smart contracts chains, we have smart contracts. And so on IC, the canister is a smart contract, but on the IC, it's like a smart contract on steroids, because it's a smart contract that holds the state, but it can hold very large amount of state, like currently up to 400 gig of storage in a single is available for a single canister in its own isolated state. running on the internet computer. So yeah, I don't know if that was also clear in addition to what Mr. Confidence said. There's a question in the chat.
Okay.
Okay, there's a question from Shadrach. What is the main function of a canister? What do we use canister for? What type? Yeah, so like I said, like it's the smart contract on the internet computer, right? It runs your code on the internet computer network, right? Whichever language you write in, Motoko, Rust, Python, JavaScript, it all compiles to WebAssembly. So in principle, you can use any language on the internet computer as long as it can compile to WebAssembly. So a canister then is just that container, that small container that isolated container that is running your code on the internet computer, and it is replicated among the nodes in the network, like in the subnet, let's say, as it's actually on the internet computer. So yeah, the canister is where you build your applications. There's front-end canister, there are back-end canister. Front-end canister, they'll be holding your state, like your front-end, your JavaScript, HTML, or your frameworks you are using, Vue.js, React, right? That's the front-end canister. The back-end canister will be holding, usually, if you're using Motoko, it will be holding Motoko. If you're using Rust, it will be holding Rust, etc. So yeah, you use the canister to develop on the internet computer. That's the building block. That's the building block. Okay. Cool. Thank you.
Awesome. Any further questions on canisters? Anything that needs to be clarified? Is everyone happy? Okay. Okay. So now that we have cleared up and we have understood the canisters, we can now move on to the common programming concepts in Motoko. So we'll start by talking about variables that you'll find in Motoko. Okay. So a variable is a value that has an arbitrary name, and it is defined by a declaration. In Motoko, the variables can be declared using either let or var. Sorry, that is icon. So we can either declare our variable using let or var keywords, and then it is followed by an assignment operator. So let's take a look at let first. So variables that are declared with let are meaning that their values cannot be changed once they are assigned. So let's look at an example. If we say let name be equal to, or let's just say number is equal to 1. This number that we have assigned to this variable name number is not cannot be changed. So this is immutable. So go by. So immutable means okay. Then variables that are declared by var are mutable. So we can have an example as var, and we can call maybe number 2 or number 1. So we avoid confusion. So this is mutable. That means once you have declared it, it can be changed. Okay, we'll look into these two different things. Okay, so the syntax convention when you are using or you are declaring variables is to use what we call lower camel case. So if your variable is being defined by probably 2 or 3 words, you use lower camel case. I'm sure most of you have seen this. Okay. So an example of a lower camel case is maybe student name. So you say student, and then you put a camel case on the name so that it's readable and easy to understand for everyone who's going to read your code. Now let us look back at let here, which you say is immutable and cannot be changed. Once we have assigned a number to this variable that we're calling number, we cannot set another number to it. So if we say let n, let number be equal to 1, we cannot go ahead and assign another number to it. Okay, like this. You see, we'll get an error here. We have an error that said expected mutable assignment target. So here it's just telling us that where we are targeting here, this is immutable. But if we say number 2 here, you will see we will have no error, because it means that once we have declared number 2 to be equal to 3, we can change it number 2 to be equal to 2. Okay. Then, now that we understand variables, we can look at the types. Okay, so the Motoko language places a strong emphasis on types and is more strict in enforcing them compared to other languages like JavaScript and Python. This strictness serves a purpose as it helps prevent errors and issues when you are running your code. Motoko has static types, which means that we find a specific type, which is determined before the program runs. So I'll just show you an example. So the compiler checks each use of the variable to avoid errors that may occur during runtime. Then to assign a type to a variable, we use the full colon symbol. And this is called type annotation. So an example. So if we have, let's say, let age, from the previous example that I had written, you saw I just said let number be equal to 1. Okay. But in Motoko, what is actually done is you say let age. So age is a natural number. There's no age which is negative, right? So all the positive numbers on Motoko are called natural numbers. So the type that we have is called natural number. So we just denote it by nat is equal to, I say 3. Okay. So this is how you actually write or you define your variables. You actually assign a type and just say which type it is. And remember, we use a full colon to annotate this. Then an example of a text, you can say let's type text. This type is called text. be equal to students Zambia. And always remember to close all of your statements with a semicolon. Then we can have another example of a Boolean value. So we can have maybe open of type. Have this. It's called bool, which stands for Boolean. Is equal to false. Or we can say true, whichever you prefer. So again, we only have two states. We have true, false. So we can generally omit the type declarations, like the first example, and the Motoko compiler will automatically guess the type to the variable based on the first value that you provide. So let's say when you just type, let's age 2 equal to, right? Your compiler, when you run the code, will automatically just assign this to and that, because this is a natural number. Okay. So sometimes if you want to remove that confusion on runtime, sometimes it's best that you just specify what type that is. Comments you've seen, I showed you how to write a comment. You can write a comment. And that's how you write comments in your code. Then we move on to functions. So this, like I specified before, whenever you are starting to write your code in Motoko, you need to start by writing or start by defining an actor, should I say. So we can look at this, and then if you have your actor, you can put your code inside, like I had specified here. So let's just look at an example of a function that is within our actor. So let's look at something like, let's write a function that's is a kind of probably a counter or something like that. Yeah. So we can name our function. Then we can define our first variable. So we can say var count, and then it is of type natural number. So we are going to be counting from 0. And now, when you are writing our function, we first use or define if our function is public or private. So we'll start by looking at what is public. So you start by writing public, and then you write the keyword func, which stands for function. Then you specify the name of your function. So we'll call it setCount. And then within our brackets, we can specify what that function is accepting as an input, or that is the arguments, have been taken by our function. So let's just say it is taking a number, and the number is of type nut. And then here we specify our return type. So after the keyword async, which means which stands for asynchronous, we will then just specify the type or the return type action. Okay. Now we can then just say count and assign it to our input. or the argument that we are taking into the function. And then we can return. That must be it. So here we have public. Again, just to repeat how we write our function. The keyword, we have public, and then we have the keyword func, which is used to declare the functions. And then it is followed by the name, which is set count. This is the name of the function. And then after that, you can also use camel case for you to if your function has two words. So as you can see here, we have set count. So you use camel case. Then once we have our function here, you can go ahead and deploy. So when we deploy, we are then installing our code into a canister. So I'll just go ahead and install. So as you can see here, we have the button that says install. And if you can see at the bottom here, it is saying that it is requesting a new canister ID. Then it got the canister, and this is the identification of that canister. And then the code has been installed at canister, this. So we can open the Candid UI. I'm sure we have all seen the Candid UI. Okay, I've opened it on a new tab. I hope you guys can see it. Okay. So if we go back to our code, we have our function here that is called setCount. If we come back to Candid UI here, you will see setCount. And it specifies what it is taking as an input and what it will return as an input, which is a natural number, and it will return a natural number. So let's just assign a new value. Let's just say 2. Then we say equal. Okay, so we have assigned 2 to our counter, and here it is returned the value. If you can see also here, it is returned 2. We can put 10. And then it is assigned another number to our function. Okay. Any questions on this before I proceed? Do we understand? And in the morning, there was somebody who was confused about, I don't know if it was confused or they wanted to understand the Candid UI. I hope you now understand the Candid UI and how you can interact with it. So yeah, any questions? Repeat on function declaration. Okay. Sure. Okay, so when we are setting, like I was saying, our function. So this is how you do it in Motoko. I know it's different in every language, but this is how you do it in Motoko. So like I said, the first thing that you do is use the keyword public. Alternatively, you can use private. What this means is that this function is not going to be accessed by any other function that is out of the canister or the code that you're writing. But if you use public keyword, that means it can be accessed by other functions that are outside of your vector. Also, you can just leave the public keyword and you just write func like this. And then your compiler will know that this is a private function. But if you want your function to be accessed by other canisters or maybe by other actors, then you need to use the keyword public. And then after that, you can call it, you can use the keyword func, which is func, and then you name the function. So you can call this set count, or you can say this set number, I don't know, or maybe set name. It's all up to you which name you want to give your function. And then within your brackets here, you specify if your function is taking any arguments. If it is not, you just leave it like that. Okay. But here we want to take some input from the user. So we will have to specify that we are taking n, or we can call this a number, or we can call this a name. If this is a name, then we have to change this to text. This is of type text. And we'll also return text, because if we take text, we cannot return a number unless we do another function that converts the text into a number anyway. But anyway, we don't want to go there because then it is complicated. So we can then say this is name, and then we can return. So we have name, text, and then let's see what the error is. An expression of text that cannot produce a nut. Okay, so here we can say student name. Text. So since this is a variable, we can say probably what name can we give it? We can just say, I don't know why that name came into my mind. Then now we can say student's name is equal to name and return. Yeah. I'm not listening. Okay. So this is the same. So here you specify the input that is going to be taken in from the user. And then you also specify the type. And then after you have closed this bracket, you put this full colon. And after this full colon, this is where you put the keyword async. And then you specify the return type. So this type that is going to be returned here is what you specify here. And then within your curly brackets of your function now, you write whatever function that, or whatever the functionality that you want to write. And then you return whatever you want to return, which should also match with this. Okay. So for example, if we put not here, you will see that we will have an error. Right. So our return type will say an expression of type text cannot produce expected type of nut. So here on this function, we are expecting to get a return type of nut, but here we are returning a text. So that is the reason why we have this error. But if you just then say again, you can also then redeploy this. So you have two options of either reinstalling your canister or you can upgrade it. So let's use the upgrade. So upgrade is just, this is just a warning. You always get it when you're upgrading your canister. It says upgrade is not backward compatible. So that means the method that's, whatever changes that you have made, you cannot always go back to them. So it's installing again. Then it has been installed. So go ahead and open the canister, the candid UI again. Let me share this tab. So we didn't change the name of our function. It's still okay. It's still set count, but we can just put another name. So you just put William. Cool. Then now it is returned William, just like we expected it to do. I don't know if that was clear. Was that justified? Okay, so it just takes a little bit of some practice for you to understand how this actually works, or how you can actually define your function, the variables, working with variables, and also mentioning the types and the likes. This is just something that you get used to by actually doing the practical thing. Okay. The actor, is it similar to a class? And do all functions behave like an endpoint? Mr. Enoch, do you want to take that one if you are there?
The actor, is it similar to a class, and do all functions behave like endpoints? Yes, for the first part, yes. Yes and no. You can make an actor a class, and yes, it can behave as a class. There's actually a system of like creating your canisters dynamically. So once you have your actor, if you declare it as a class, you'll actually be able to like create another object of the same actor. So yes, it behaves as a class. And do all the functions behave like endpoints? Not all of them. You can make them endpoints. So some functions can be private, some functions can be public. Public functions can act as endpoints. But yeah, and also public shared can also act as endpoints to other. You can also do what is called canister calling, so that one canister can call each other. So yeah, if you make them public, they can be endpoints.
Thank you for that, Mr. Enoch. How do you run this in VS Code? Gerard, not sure if you were in the first lesson in the morning.
Yeah, try to watch the lecture we did in the morning. You'll see everything. The link is in the group. And tomorrow session we will do as well. And yeah, maybe with our time, tomorrow morning we'll introduce you to the homeworks as well, so that you get started.
Okay. Yeah, so our time is past 9 now. Maybe we can take one question and then we can end this session. Any other further questions, ladies and gentlemen? Okay, that's awesome. So I hope that everybody has understood. Tomorrow we'll continue, and then we'll introduce you to the homeworks that we have, that we expect you to do, and it will become more practical for you when you're doing those homeworks to actually get started to develop the application. And you can always do more if you feel like you can do more. Then we'll take it from there. Otherwise, thank you, guys.
Mr. Confidence,
let's yes.
Mr. Confidence, one comment. Yeah, it's possible that some students have maybe 2 or 3 have joined using one gadget. So maybe they're economizing on data and the like, but we're interested also in the statistics of those who are joining, so that at the end of the program, those students can also be certified. So we're also just interested in case you join and then maybe you are 3-4, they can give us that information. Maybe just write in a text to say, okay, here we are 3 or there we are 4, so that we can compare. At least we know how many are attending these lessons, because it has been noted that some had maybe 2 or 3 joining using one gadget.
Laptop. Okay. Understood. And thank you for that, sir. Yeah, so maybe we will share a form probably that we can get that information from the students. Okay, guys, so I think that's it. Mr. Enoch, you have something to say?
No, let's meet tomorrow.
Okay. Thank you, guys. Have a good night. We'll see you tomorrow morning. Good night.
Good night.